Agrarsense is a CHIPS GU project. In this use case, we're focusing on agricultural robotics. With different partners, there's a work on developing sensors for harsh agricultural environment. This video will be presenting also the different sensors and the different partners in this project.
My name is Martin Roke. I'm representing TT Control, which is a company developing electronics and embedded control systems for highway mobile machinery, like tractors, like excavators, and anything like that. Within the Agrarsense project, we are developing an embedded edge computing platform, a prototypical platform that is capable of handling all the data collected by the mobile machine directly on the machine itself, without having to be dependent on external computing resources. The Agrarsense project offers TT Control the possibility to develop our own platforms in a further way, and also to see how much data, what kind of data can be collected, and how our platform reacts in real-world environments.
Hello, my name is Andre Severa. I'm coming from University of West Bohemia, where I'm working as a researcher and NTIS Research Center. And together with Smart Motion company from Czech Republic and Agriculture company, we developed one result of the Agrarsense project, which is called Advert. We are focused mainly on the robotics. Smart Motion company are mechanical engineering company, so they helped us with assembling the hardware. And Agriculture is a coordinator of the use case 4, and also they're working as a developer of the vision software. Advert is a robotic arm implement. Basically, it's meant for the pruning in a vineyard, and it consists of 3 main parts. The first one is the trolley itself. It contains the power supply, also necessary control computers, and all the wiring, which are connected to the robotic arm. The robotic arm itself has a 7 degrees of freedom plus 1 rotation axis, so it sums to 8. And then at the end, we developed the end effector. The end effector is a gripping tool with the pliers. So basically, the pliers can hold the canes, and the scissors cut them. And to be able to navigate, the Agriculture company developed a vision-based software, which is using those stereo cameras on the top to find the proper canes for the pruning. We also have one more camera on top of it, which we use for the surveillance purposes, so that we know that the pruning went well, even remotely.
Hello, my name is Łukasz Sigielski. I'm project manager at the Gdańsk University of Technology. What we are doing in this use case is we are providing wireless communication systems for the needs of different components brought here by the partners. So this small device allows you to connect it to different types of components which are visible in the background and send the data using different type of communication methods such as LoRa, Wi-Fi, or 5G. So this project gives us a great opportunity to verify our solution in a harsh environment and enter a new domain, which is agriculture domain.
partners are working on multispectral cameras as CSEM. Partners are also working on thermal cameras.
Hello, I'm Jan Erik Holter. I'm from a company called Ideas in Norway. At Ideas, we design and delivers ASICs and systems for radiation detection. And for the Agrarsense project, we have developed a thermal camera that we have here. And the thermal camera is used for detection of people and animals in the vineyard.
Hello, I am Peter Bartak from Smart Motion company from Czech Republic. Smart Motion is a company focused on industrial design, single-purpose machine design and industrial prototypes. In Agrarsense project, we are responsible for mechanical design of pruning robot attachment. The Agrarsense project brings us new opportunities and new experiences in another field than we are usually working.
Morning. My name is Antonin Delas. I work for Agriculture, which is the use case leader of the agri-robotic use case on the project Agrarsense. As integrators, we manage to integrate every sensors that are provided by the different partners and to manage the data from the low-level stuff into the high level. So the low level means the communication between the different CUs and the sensors, which means LiDARs, RGB cameras, thermal cameras, multispectral cameras, guidance and positioning systems, and to manage that data flow until the final needs of the farmer, which is the visualization and the monitoring of the systems through directly the cloud platform. We also handle the actuators management to make the robot stop when there is specific obstacles, like the living obstacles, the unexpected ones, and also the vine pruning, which is done by the robotic arm at the end of the robot.
We can do both the pruning and also we can take out the branches out of the vineyard and place them here on that ground, where in another round this autonomous tractor will destroy these branches and make it as a fertilizer.
We're working now on the major milestone, which is the field testing for full system integration and testing. The next steps will be having a full season of testing in order to validate the algorithms and the full functioning of the system.